Hello friends, this is ER Patel Parth and here we are going to do transient thermal analysis of piston and piston component. Okay, here you can see this is the connecting rod, this is the crankshaft and this is the piston head, and you can see this is little bit piston pin. Okay, so we are going to do this analysis. You can see it here. First I am going to open transient structure analysis from here. First we select the engineering data, in which we select the material. From general material we can select any kinds of the material. From here you can see the different kinds of the material here, and different kinds of the property you can see it here. In general material we will select aluminum, stainless steel. Okay, here I will import the part from geometry. Import external geometry, you can import the part from here. And how to import the part from our favorable design software like the SolidWorks. So you can watch my first video, or you should watch my first video. Here I am going to open in step extension. First I have to select add material, and to open the part, to apply generate, then it will open. Look at this, you can see it here. This is the crankshaft connecting rod, piston pin which is connected with the crankshaft, and this is the piston head. Okay, then open the model. Our model is open. Then we apply, first we apply the material from here. Here the name is ground for the crankshaft, but I changed the name from here. This is the piston pin in the green region. Part 2 is connecting rod, and this is the piston head. For the crankshaft, I apply it here stainless steel. For the piston pin, I'll apply it here aluminum. For the connecting rod, I'll apply stainless steel. Then for the piston head, I'll apply aluminum alloy at here. For the crankshaft, piston pin and piston head, we applied at rigid. We applied at here the rigid for the better solutions. And this connecting rod means part 2 is at here the flexible. Then this is the by default contact generated here, so we have to delete it. Then we have to apply the some joint at here. First the fixed revolute joint at here. You can see at the body to ground means the one part is body. First I select the revolute joint, body to ground revolute joint. I'll show you what the body to ground and body to body joint. For the body to ground joint, I'll have to select this one is body to ground joint. Okay, you can see it here. The first part, one component is connected with the ground means fix. At the configure, you can see it here, the better visualization at here. You can see what kinds of the movement you can see. This part is fixed, only the upper part is moved. If the body to body contact joint is occur at here, then two body in the motion joint. I'll show you for the revolute body to body this two component joint. First I have to select these two part, then I'll hide this part for the better crankshaft. I hide this one to selecting these two part. You have to ensure about this right click. If the right click is not occur at here, then something is wrong happening. Show body. Okay, I'll show you what is the body to body. This is the body to body joint. Okay, just like the configure. Look at this. The two part, two body is in the motion. Okay, two body. Then another body to body revolver joint. I hide this piston head for the better visualization of these two components. Apply another one. Okay. I selected this inside and this because this is in the revolution joint. Okay, revolution motion. So that's why I selected it here. Show body. Then okay, again I have to hide this one because this pin is in the fixed joint with the piston head. Okay, sorry, it's not the body to ground, it's a body to body joint. You can also change from here. First I select this and then I show this component. And apply. This pin is in the fixed joint with, you can see also the reference body view which I selected at here, and then also for the piston head which I selected at here for the mobile. You can see it here, the mobile body view. You can also the ensure from these two reference body. Then are the one fix body to ground. This one is body to ground but not in the fix, it's a translate. It's a translation in the motion. Okay, because the piston is moved upward and downward side, this pin is fixed with, this pin is a fixed with piston head, and this connecting rod is connected with the piston pin, and another side of the connecting rod is connected with this crankshaft, and this crankshaft is connected with in the fixed revolute joint. So I can show the better how it's moved in the config. You can see the better whole body how it's moved. Okay, first you have to select this joint and then configure, and you can see it here, this highlighted, you can see it's not moving. Something is you can see it here in the better way. Look at this how it's moved. Okay, so first we going to generate mesh. Okay, from sizing you can choose the different kinds of the method from here: proximity and curvature, curvature, proximity, and the fix. But when you apply, when you will apply the proximity and curvature, then it will take too much time to generate a mesh. Okay, and then go for generate a mesh. It's already done by me. Why the mesh is not generated at here? Because we confer crankshaft, piston pin, and the piston head in the resid. Here just only connecting rod is in the flexible mode. That's why the generators are generated in the connecting phase, because only the analysis is done at here, not done at here. Okay, so our joint is ready. Then go for the transient joint load, because here you can see all the joint load is available. So that's why we have to select the joint load, and here we select first ground to ground revolute, because when it move, then all the component is moved behalf of this. Then here rotation, most amazing and paramount things at here, and in analysis setting first, then after we go for the joint rotation. In the analysis you have to select the number of step 360, and for the current step you have to go for this tabular data. Okay, you can find it here in the tabular data. Then here the right click and select all the step. Then you can see what kinds of the change is done. Multi-step. Okay, you have to ensure about this multi-step, and this 360, this auto time stepping off, then time step 1 second, then time integration off. When you apply these things, then and then you will get the result at here. Why we have to apply the 360? 360 means 360 degree. It rotates the 360 degree, means one full revolution. That's why we have to apply the number of step 360, and here you can see. Then you apply the 360, then here in the tabular data you can find the 360 steps. Then we have to go for the joint rotation. In the joint rotation you have to, for the magnitude, for apply the magnitude, you have to go for the tabular time. Okay, first how to select the joint, I show you, I show to you. Joint rotation, here you have to select. In these things you have to just apply the bottom side 360, then it will take automatic. Okay, 359, 357. It doesn't need to apply this all things. Okay, and you can see also here 1 2 360. Joint rotation is done. Then go for the solution. We select the total deformation of this connecting rod. One mice is strain and stress. Okay, then go for the solve. It will take too much time to done it, so I hide this one. You can see we get the partial result at here. Okay, we find out that these kinds of the error, but you doesn't worry about it. Sorry for the disturbance. You can see it here, we get the partial result. we have to ensure about these right things. Okay, so nothing to worry about it. We get the result. You can see in the total deformation we get the result at here. So for the getting full solution, we have to go for the main page and go for the update project. When you apply the update project, then it will update totally. It will take the few time, and also we have to ensure about this all the right things. When I give to the update project, you can see the setup is okay, the model is right. Before I applied the update project, this in this two model and the setup is in the sign like solution sign. You can see it here, we get the full solution at here. So for the total deformation animation, we have to go for first click to the solution information, then back to the total deformation. You can also find out the solution information, all kinds of the solution information at here. We also get the equivalent elastic strain at here, okay, where the strain is too much. Strain value, maximum strain value is 4 into 10 raised to minus 13 mm is maximum. You can see also the graph here, okay, for the total deformation. You also see the graph at here for the total deformation graph for up to the 0 to 360 step, which we applied at here in analysis setting. 360 step, okay. In equivalent stress also we can find out the graph at the 150. Graph is maximum at the 150 step, means 150 degree, and also at the equivalent elastic strain we also find 150 degree at the maximum. And for the total deformation we find the maximum at also around the 170 to 180 degree maximum, okay. Then we see the what kinds of the total deformation is generated at here in the animation view. So for the better visualization in the frame rate you have to select 100, and for the this value you have to select the 10 second, and then go for the this icon for the animation. It generate the animation video at here. I select the desktop and I apply the name at here the one, okay. So it generate the animation video, and you can also click to the this animation button to generate the animation. It reached at 14 degree, so move up to the 14 degree at here, then it's reached 21 degree, 25, you can see it here, 25 degree, 29, 32, 32 degree, so move 32 degree, 36, 40, And you can also find out the maximum deformation 140 mm means 14 centimeter up to the 14 centimeter means half foot deformation we it generate at here for the connecting road at the maximum at here at this level. When it complete, then you can see the better at here in the red region 58 degree. It's a downward to the 58 degree. And in the tabular data you can also find out the information at here for the what step for the time 2, what's the deformation it generated at here for the time 2. When it completed I will show you. You can see it here it's reached up to the 112 degree below side, and this color is in the different way. You can see it here in the yellow. So yellow at here the 109 mm deformation generated at 130 134 at the red region it's a maximum. Okay, it's a little bit red. Okay, yes, it's a fully red means 140 mm deformation at the around the 150 degree. It's reached at 283 degree. At the 283 degree it's in the green region, green color, so you can find out the green deformation at here the 62 around 62 to 78 degree 78 mm deformation you can find out at here. When it's move upward then the deformations will remove, deformation will reduced. You can see it here the downward side color goes. At the 330 degree you can find out the region blue region means 15 mm deformation generated at here, while the 30 around the 30 degree generated at here. And at the 360 degree you can find out zero deformation at here. Our result is ready. You can see at here at the maximum region you can see at here in the red. I told you this is the maximum deformation at here and maximum stress also generated here. You can see in this green region this strain is generated around. You can select the prop and you can see what kinds of the stress at here 1 2. Here we will find out the 2, then I go upward side, then it reduce, the strain is reduced and also it increase, it reduced. Okay, and equivalent stress, for the equivalent stress select the prop. You can see it here what where the stress is maximum at here 6 into 10 is to minus 9. Then I go upward side, it reduced. Okay. And this things also in the total deformation drop. You can see how the change, how it is changed. Okay, I told you about it. In the tabular data we can also find out the maximum and the minimum deformation at here. For the first, for the 2 degree, we find out minimum deformation at here like this and maximum deformation is like this. Okay, so when we have to submit this data in the company, so you can submit or we can submit the data from here, minimum and the maximum deformation at what degree. You can find out it here, any degree. Okay, for 360 degree it's a minimum. For what the maximum deformation at the what degree, we see it here around the 143 degree, so 75, 144, 75.3. So we find out the 146 degree maximum deformation at here, 146 degree, 75.809. Then sorry, we find out the maximum deformation at here, 79.125, 79 at here. Huh. For 180, for 180 and 181 degree, we find out the maximum deformation at here. For the 2 degree, you can see it here, 79.339. In the above side it also reduced and at the below side it's also reduced. So we can see it here, the 180 degree and 181 degree, we find out the maximum deformation for the connecting rod. Okay, are the saved animation is ready for the one. So I'm going to open it in VLC. You can see it here how it's a move and how the stress is generated at here and the color is generated at here. Okay, how the color is changed. So our the solution is ready, all the information is ready. So thank you so much and subscribe my channel.